In this tutorial, I'm going through Leaving Cert Higher Level 2023, Paper 1, Question 1. First part of this question, we're given a modulus equation. If you want to study the theory on modulus equations, go to the website and look at Algebra 15, which goes through how you would do a question like this. There are two ways to get rid of the modulus signs. We can either square both sides, or we can simply let the modulus equal to plus or minus 11. And in this case, it's a lot easier to do the second one there. We're just going to let 5 plus 3m equal to 11 and 5 plus 3m equal to minus 11 and solve. So here I've split it into two. I let 5 plus 3m equal to plus 11 and I let 5 plus 3m equal to minus 11. Bring the 5 across, it becomes negative, and you just solve it. It's two very simple questions. In one case, m equals 2. In the other case, m equals minus 16 over 3. In part B, we're given the following equation, and we're asked to get k in terms of h and j. If you want to practice similar questions to this, go to our website and look at Algebra 14, which is similar questions. It's manipulation of formula. There's a number of different ways of doing this one, but certainly the first thing you should try is to eliminate the fraction. The first thing I did was eliminate the fraction on the right hand side by multiplying both sides by j plus k. If you multiply the right by j plus k, you just get k. If you multiply the left by j plus k, you get j plus k over h. Then to get rid of the fraction on the left, I simply multiply both sides by h. The fraction disappears on the left, and on the right you get k times h. I think a lot of students might get stuck here. What you should do now is move all the k terms to one side. So I took this plus k, I subtracted it, and I end up with the k terms on the right hand side and the non-k terms on the left hand side. Then all we have to do is factorize out the k. So on the right hand side, if you factorize out k, you're left with h minus 1. To get k on its own then, you divide both sides by h minus 1, and your final answer is k is equal to j over h minus 1. Okay, in part C of this question, we're told that x squared minus px plus 1 is a factor of x cubed minus 2x minus 3r. We're asked to find a value for p and a value for r, and we're told that p is less than 0. Now, questions very similar to this. We've done like 5 or 6 questions identical to this in Algebra 13, so it's worth having a look at that. The theory behind this, first of all, is that if this quadratic is a factor of this cubic, then that means we can divide it in. We can divide it in and the remainder will be 0. So that's the principle here. We're going to divide the factor into the cubic, and whatever the remainder is, we can let it equal to 0. There's just one little caveat here. Don't forget that if we tried to do this question, it wouldn't work out for us, because there's no x squared term in our cubic. So in order to do this one, we have to add in a 0x squared. If we do it like that, now it's going to work. In other words, the power of x has to decrease by 1 each time. So now I have an x to the power 3, an x to the power 2, an x to the power 1, and then an x to the power 0, or no x. So let's just go through our division here. The first thing we do is divide x squared into x cubed, and that simply gives me x. Then we multiply x by these three terms. X by x squared is x cubed, x by minus px is minus px squared, x by 1 is simply 1x. Remember, the third step in long division is to subtract. So we're going to change our signs and subtract. This becomes a minus, this becomes a plus, and this becomes a minus. Now the x cubes will cancel. 0x squared plus px squared is simply plus px squared. Minus 2x minus 1x is minus 3x. And step 4 is you take down the next term, in this case minus 3r. Now we just start our process all over again. We're going to divide x squared into px squared, and that gives us plus p. Then we're going to multiply p by the quadratic. P by x squared is simply px squared. P by minus px is minus p squared x, and p by 1 is simply p. Remember, step 3 now is to change the signs and subtract. So I change all my signs. This becomes a minus, this becomes a plus, and this becomes a minus. The px squareds will cancel, and now I'm left with my remainder. I think this is often the point where students go wrong. What we're about to write down now is our remainder. And remember that because this quadratic is a factor of this cubic, the remainder has to be equal to 0. But we have two separate remainders. The first remainder is what's to the left of this line. It's the terms in front of x. and the other remainder are the terms that don't have x's in it. In other words, the x terms here will cancel each other out, and these terms here will cancel each other out. So the first remainder is just the coefficients of x. The term in front of x on the top is a minus 3, and the term in front of x on the bottom is plus p squared. And that's my first remainder. I know that that has to be equal to 0. My second remainder is the term without an x on the top is minus 3r, and the term without an x on the bottom is minus p. That's my second remainder, and I also know that that has to be equal to 0. Now we have enough information that we can just solve these equations and find a value for p and a value for r. Let's start with this one since it only has one unknown in it. Obviously the first thing we do is we would add 3 to both sides. We get p squared equals 3. Remember, if p squared equals 3, there are usually two possible answers. Usually, like, the square root of p squared is p, but the square root of 3, you could write it as plus root 3 or minus root 3. However, in this question, it said that p has to be less than 0. So that means that when we get the square root, we're not going to take plus or minus root 3, we're just going to take minus root 3, because the question says that p has to be less than 0. So your answer for p is minus root 3. Now that I have a value for p, it's relatively easy. You just sub it in over here and we'll get a value for r as well. So on the left hand side I have minus 3r, and minus p, well obviously that's actually just minus root 3. We're just subbing in the answer we got here over here. And you'll notice now that we've got one equation and one unknown, which means it's simple enough to solve this. So minus by minus gives me plus root 3. I'll simply subtract root 3 from both sides, and I get minus 3r equals minus root 3. Now, since they're both negative, I might multiply both sides by minus 1 or something, and I'll get 3r equals root 3. And finally, to get r on its own, simply divide both sides by 3, and your answer is r is equal to root 3 over 3. Which, as we've discussed going through trigonometry, another way of writing root 3 over 3 is 1 over root 3. So those are your two answers for p and answers for r. Now in the exam they actually accepted if you left your answer as root 3 over 3, so you didn't have to write it as 1 over root 3 in this case.